Hello, here we have question 1 from the sequence homework on myimaths. They've given us a bunch of sequences and asked us to work out the next term of the sequence, okay? So, let's look at the first part here, one of these ones. These ones are called recursive sequences. What does that mean? It means that you need to use the previous term to generate the next term. So normally a sequence looks like this: A1, A2, the first term, the second term, and so on and so forth, the third, fourth, fifth. Then we get to AK. That's any term, really. Okay, that's any term. It could be, say, A10. The one before it, the one preceding it, would be A sub k minus 1, or A9. The one after it would be A sub k plus 1, or A11. Okay, that's what this means. So AK is a term in a sequence, and then we use it to find A sub k plus 1. That's the next term in the sequence. So we use the previous term to generate the next term. So if k equals 1, what's our formula look like? So we're going to have A1 there, okay? And we will have A1 plus 1 here. So we use A1 to generate A2. So it looks like we need A1 to get the ball rolling. The only way we can get this started is if we know A1. So let's have a look here. We have A1 is going to be minus 2. Now we can get the ball rolling. Minus 2 plus 10 will give us the next term, and that is 8. Now we use A2 to generate the next term, A3. So now we have A2 is equal to 8 plus 10 to generate the next term, so that's 18, and so on and so forth. This one just appears to be adding 10 to the previous term every time, so plus 10, plus 10, the next one will be 28, then 38, and so on. Okay? So, there's a famous sequence, a very famous recursive sequence, the Fibonacci sequence. You've all heard of it. What we do is we use the previous two terms to generate the next term. So if our term is A sub k, then we use the previous two terms, A sub k minus 2 and A sub k minus 1. Okay? So for this one, you actually need two terms to get the ball rolling. Okay? So we have 1 followed by another 1. That's the Fibonacci sequence. Then we need the previous two added together, 1 plus 1, to generate the next term. Then we use these two previous terms, 2 plus 1, to generate the next term, and so on, and so on, and so on. That's the Fibonacci sequence. Okay? Let's go back now. Okay. Alright. Now, there's other ways. There's nth term formulas that also generate sequences. So let's do a couple of these answers. For the nth term formulas, you simply have to substitute 1, 2, 3, etc. into the formula, and it will generate the terms. Usually a pattern emerges. Let's find out if a pattern is going to emerge. So for the first one, we're going to sub 1 for k. So 2 to the power of 1 plus 3 is 5. Now we're going to substitute 2 for k. 2 to the power of 2 is 4 plus 3, 7. And so on and so forth. 2 to the power of 3, 8 plus 3 is 11. Let's do one more. 2 to the power of 4, 16 plus 3 is 17. That looks to me like we just keep on adding powers of 2. So we add 2, then we add 4, then we add 8. So the next one we'd be adding 16. Okay, so the next one would be 33. Okay, and that's how you do these ones. This is a geometric sequence. It's going up by powers of 2. Okay, so the next one. This is just a random sequence. It's just interesting. If we sub 1 in for k, this becomes -1. So we have 7 minus 1, 6. If we sub 2 in for k, we have plus 1. Negative times a negative is a positive, only in math. Okay, so 7 plus 1 is 8. And then we come to the third power of -1, we end up with -1 again, because plus 1 times -1 is -1. So we end up with 6 again. And here's our pattern, 6, 8, 6, 8, 6, 8. Okay? I did want to look at one more thing. Okay. I did want to look at one more thing just down here. Here it is. So, the Fibonacci sequence actually also has a formula you might be interested to learn. This is actually an nth term formula for the Fibonacci number. And what's interesting is it contains root signs, root 5, but at the end of the day, when you substitute values of n, meaning n equals 1, 2, and 3, you will end up getting a non-irrational number. So our famous sequence, 1, 1, 2, 3, etc. Try it for subbing 2 in for n. See if you can get our famous second term in the Fibonacci sequence. Substitute 2 for n. See if you can get the answer, which you already know. Okay, bye-bye.